Now at this point, often students are getting a little stumped up by the negatives. So I want to take a minute and just focus on the rules for negatives and give you some shortcuts. If you notice on the first problem, we had a positive 56. A positive 56, we could either have a positive times a positive or a negative times a negative. In this case, we use two positives, okay? Notice if there's a positive, then the signs are going to have to be the same. On the second problem, very similar. We have a positive 32. What were my signs? Well, either positive positive or negative negative, but my signs were going to have to be the same. Now on the third one, my sign was negative on the third term. When there's a negative product, the signs have to be different. That's the biggest key to dealing with your signs. If your second sign is positive, then your signs in your answer will be the same. If the second sign or the sign of the third term is negative, then your signs will be different. So before I do the next three problems, I'm going to scroll down here and show you some examples. So the four types of problems are going to be x squared plus bx plus c, x squared minus bx plus c. Then we could have x squared plus bx minus c, and x squared minus bx minus c. The two that I did in red both have a positive on the c. Because they have a positive on the c, I know that their signs are going to be the same. So my answer will look like x and x in the front, that's for sure. I know there's going to be two numbers here, but I didn't really put numbers in these problems. I just put letters, so we're not going to worry about that. But the signs are going to be the same. So which signs are they? Well, in order to find out what signs they are, you look at the first sign. So this problem will turn out to be x plus some number and then x plus some number. Now in the second red problem, we have another plus. That plus on the c tells me that my signs are the same. Same signs. And then I ask you, well, what signs are they going to be? In order to tell what signs they are, you take the sign of the b. They're both going to be whatever the b sign is. Alright, how about on the third one? The blue one. Now I did these in blue because both of these blue problems both have negative c's. The negative c's tell me that my signs are going to be different. I have different signs. So on these, I know I'm going to have one x plus and the other one's going to be x minus. But clearly the two blue problems aren't exactly the same, so why are their answers the same? Well, they are for now. We do have two numbers in here. One number is going to be bigger than the other number, like one's 3 and one's 5, so 5 is the bigger one and 3 is the smaller one. How do you know which one's which, right? So just because they're different doesn't mean I know my answer. I have to know which one's the positive and which one's the negative. It's not quite as easy when they're just the same signs. So if they're different, to tell which one's which is the sign of b goes with the bigger value. So the negative will go with the smaller value in this case. Well, on our last example, x squared minus bx minus c, we know the signs are different. Because the b is negative, my sign negative will go with my bigger value. And the positive will then default to the smaller value. So using this, let's do a couple more problems. So on the next problem, 3b squared minus 9b plus 6. First of all, I've not taught you how to deal with problems when there's a 3 in front. But that's because you have to factor out a GCF. So first thing I'm going to do is factor out a GCF of 3, which leaves me with b squared minus 3b plus 2. I'm looking for two numbers that multiply to 2, yet add to negative 3. My skeleton answer, don't forget to keep your 3. I know I'm going to have a b in the front and a b in the front. Let's just look at our signs for a moment. I know this 2, or my C term, is positive. This tells me that my signs are the same. Well, what signs are they going to be? Well, I look to the middle term sign, which is minus, so that means they're both going to be negative. So I'm looking for the factors of 2. Well, there's only one set of factors of 2, 1 times 2, that add to 3. Is that going to add to 3? If they're both negative, they add to negative 3. And that is my answer. And knowing these little sign rules can help you to get your answer a little bit quicker. On the next problem, I have a GCF of 4x. Now that I factored out the GCF of 4x, now I have a leading coefficient of 1, which is what I want for my easy trinomials. Don't forget to pull the 4x down. I know I have an x and x in the front. I'm looking for two numbers that multiply to negative 15 and add to negative 2 at the same time. Before we go and work on that, let's look at our signs. This sign is negative. What does that negative sign tell us? Well, that tells me that my signs of my factors are going to be opposite or different. Okay? The negative says I have to have different signs. So what are the two factors that multiply to negative 15 yet add to 2? It's either 1 and 15 or 3 and 5. In this case, it's 3 and 5. But how am I going to add to a negative 2? I know I have one of each sign, but which one's which? That's an important thing to know, right? In order to find which one's which, I take the sign of the middle term, the b term, of negative 2. This negative on the middle term will go with the larger value, which is 5. So that means 3 has to be positive. And that's my final answer. On this next one, I have a GCF of x plus 2. And now I have a leading coefficient of 1, which tells me it's an easy trinomial. The x plus 2 GCF is going to stay the same. Because I have a leading coefficient of 1 in front of the x, I know my other factors are just going to have an x and an x in front. I'm looking for two numbers that multiply to positive 2 and add to negative 3. So let's see, the only two factors that multiply to 2 are 1 and 2. Let's take a look at my signs. I know that this is positive on my C. Because it's a positive C, I know that my signs are the same. Well, what signs are they? I come in here and look at my B. My B is negative, so that means my signs have to be both negative. So my numbers we already determined were negative 1 and negative 2. So 1 times 2 truly does multiply to 2, and negative 1 plus negative 2 does add to a negative 3. So that is my final answer. Next we will focus on trinomials with leading coefficient not equal to 1 in the form ax squared plus bx plus c. I call these the hard trinomials. They're a little bit more tricky than the leading coefficient of 1, which are easier trinomials. So before we factor, again, the same that we did before, we're going to distribute and look for patterns. So some examples of the harder trinomials are where the leading coefficient is not 1. Notice this 12x squared, that's not 1x squared, it's 12, it's nothing other than 1. Also, the 12 can't factor out as a GCF, so we're going to have to deal with this 12. Again, the next one's 8x squared, and that's not equal to 1, and then 6x squared, again, that's not equal to 1. So let's first explain why these are so much more tricky than the easy trinomials. So to show you that, what I want to do is just distribute here. So this gets me 15x squared plus 12x plus 10x plus 8. And then the next thing you would do is add these two middle terms together, and I get 15x squared plus 22x plus 8. So this is going forwards, and what my goal is to start here and end here. Okay, so I would like to go backwards. So I even actually have the answer written in front of me. But if I take a minute and I just black this out right here, Now, you don't have to necessarily do that. I'm just trying to make sure that you can't, see where you're looking at. But if you're just looking at the trinomial and you're trying to get to the two binomials, our factors, I can clearly see where this 15 came from. This 15 came from the 3x times the 5x. That is so very easy to see. Then I'm going to look at the 8. Can you tell where the 8 came from? Well, sure I can. That's the 2 times the 4. I can totally see that. So the thing that's a little bit tricky is the 22x. Where in the world did the 22x come from? Well, once I unblack this out here, you can see that the 22x came from the 12x and the 10x. But when I blacked that out, you couldn't see where it came from at all, right? So the 12x came from the outside numbers, and the inside number times the inside number, it's got me 10x. But if I black out that middle 9, you don't know. So the question is, if I start with 15x squared plus 22x plus 8, how am I supposed to know where this 22 came from when I'm trying to factor it? That's why this is so tricky. The first term, ax squared, that's pretty easy. I can see where that comes from. The c, yeah, I can see where that comes from. It's this middle b term. That's the stinky part. That's the one that makes this so much more difficult. Now, there are several methods that you can use to factor trinomials with leading coefficient not equal to 1. But all of these methods are just true variations of the following two methods. So the two methods we're going to be talking about are guess and check and the AC method, also called grouping or split the middle term. So if I use those other words, they're interchangeable. Now I'm going to show you both methods, but what I really need you to understand is you only need to know one. Out of all the things that I've taught you in factoring, you need to know all of them. This is the first time you only need to know one of these, okay? And that doesn't happen very much in math, where I can say, oh yeah, you don't really need to know one of these. And once you find that you like one method over the other method, then what I want you to do is just continue to use that method until you get really, really good at it.